G'day guys, how's it going? So in this video, we're going to start looking at vectors and how we can create them, fetch items from them, and basically also iterate over them. And then in future videos, we'll talk about other operations that you can perform on vectors that can be very useful. So there are a number of ways that you can create a vector in Rust. The first one is to basically create a variable, let's say something like this, growing list, right? Because vectors are growing lists. We can say it's a vector which is VEC of type I32. And we can set this to the VEC, what we call a module, double colon, and then the function new, all right? Now, I haven't spoken about this syntax just yet, and we will get to that later. But in order to create a vector, we need to go VEC, double colon, and then the new function, right? And this will give us an empty vector, okay? So just to prove that, let's just basically print out the length of this list. Oops, like so. And we'll say it's equal to growing list dot len. Len is the function for length on the growing list if you want to see what the length of a vector is. And then we'll also get what we mentioned in the previous video, its capacity, okay? And I'm going to spell it right. So growing list dot capacity, right? Again, it's another function associated to the actual vector. Cool. Now we'll just print these out. So print line, and we'll say something like growing. Oh god, I can't spell today. Growing list capacity, and we'll set that to the capacity, and we'll do the same for length. So we'll just grab the length one here. In fact, I might swap these around just to make it easy on myself later. So I'm going to run this program, and essentially it's going to build, and it's going to spit out 0 and 0. And that's because we're constructing an absolute empty list. All right, that's what the new command does. So at this point, there is no capacity because there's nothing in there. It's not going to make any assumption that you're going to put anything in there. So that is why it's set to 0. And then length is obviously 0 because there are no items in the vector. Okay? So that's one way of creating a vector. Another way is you can do it from an array. So we could do something like this. Let fixed array list equal vec colon from, and we pass it as a parameter here, an array, right? So we can say something like 3, let's go 6, 2, and 1, right? We'll just do that. And then we can pretty much do the same as we have up here. We can just, actually, I'll just grab these 4 lines specifically. Whoops. Grab them properly. Paste them down, and then just change a few things up here. So we'll just put fixed array. And fixed array. And length goes here. Capacity goes here. And we'll just go fixed array list. I'll make that lowercase a. And I'll comment out the bit above just to make it easier to see in the console. So when I run this, well, now you're going to get a fixed array list with a capacity, which I spelled wrong, of 5 and a length of 5. Now, I did mention in the previous video that capacity will generally be higher than the length, and that's to cater for any future items that may be added to the list. But because I've used a fixed array here, basically Rust has gone through and said, oh, maybe that's all you'll ever have in this vector, right? Is this list. And in fact, the likelihood is maybe you'll actually remove items even. So in this situation, it tries to optimize it to say, okay, well, then I'm going to just set the capacity to whatever the length of the array is, right? So I know I kind of mentioned in the previous video that capacity was always going to be higher, and in certain circumstances would be lower. This is one of those circumstances. Cool. So that's how you can do it with arrays. Now we can actually also do something similar to above, where we can instantiate an empty array. Well, sort of an empty array. It's an array with no items in it, but we can set a capacity ahead of time, right? So say that we might know in the future that we need 10, well, 10 items will go into this vector, right? We can use instead of new, we can use with capacity, right? And we can pass in the length, or the capacity, sorry, to say in the future, I expect 10 items to potentially fill in here, and this will create a vector with a capacity of 10. So let me just quickly rename this. Whoops. Preset capacity list. And we'll just go through and comment these out. Whoops. It's too far. Change this to preset capacity. Interesting name there. Preset capacity, list capacity. Anyway, never mind. You can judge my naming conventions at a different date and length, and I might change this to have the correct spelling. And so we'll say preset, capacity list, capacity, and same deal here. So when we run this one, now you're going to see that the list has a capacity of 10 because that's what we defined it to be, but the list length is 0. So basically, this is good if you know ahead of time that in the future, you're going to need 10 spaces and you want to allocate it immediately so that you don't have to allocate it later, right? Sometimes you can do that in programs just to optimize for memory and speed, right? But that's just another method you can look at. Now, the 3 ways I've just shown you is by using the vec type functions, right? But there is a shorthand way. And we can use what we call a macro, which I haven't spoken too much in depth what a macro is yet, but I will in future videos. But it looks a little something like this. So we can say something like, let macro list equal, and then we go macro, we go VC, colon, and then we define the list in whatever shape we want it. So it could be an empty list. In this case, I'm going to put 3 items in there. So basically, it's essentially an array after the vec macro here. But this is how we can also create a vector, right, with I32, because it's detected it's got 3 items in here. Cool. And that works exactly the same way as the others. So we can take the same type of logic we have up here, and we can apply it to these 4 things. So now instead of it saying preset, I'll just go macro list, like so. Oops. Macro list. Change that to macro. Change that to macro, I should say. And macro. Cool. And if I run that, well, we see 3 because that's how many items we had in the macro call where we passed in the array. And the length is also 3. Again, because we're dealing with a fixed size array. Okay, that's why those 2 things are the same. So you're probably wondering at this point, when is capacity going to be higher than the length, right? During initialization, it's never been. But there must be a time where the capacity is high, because you mentioned so, right? Well, it usually happens when you start adding items to a list. So what I'm going to do is I'm going to add this as a mutable list now, and I'm going to start adding items to this vector, right? So for example, and I'll mention these in a future video, but I'm just going to quickly write out a few. So extend, and we'll just add 4, 5, and 6. Let's put a space between that. So if I do something like this, and then maybe I print out the values beforehand, and then I have to once again get everything after that to see what the new length of capacity is. So in this case, let's go macro 2. It's not macro 2, but these things are different. Cool. So if I run this, what's going to happen? Well, we're going to have our original one of 3 and 3, but it also says 6 and 6. And like, what's going on? You just added something. Well, this particular function also takes a static array, right? So because there's 2 static arrays used in this code, it assumes 6. So then I go, okay, what about if I do this? Macro list dot push. We're going to push one individual item on. So let's say we push a 7, and then just for interest's sake, let's push an 8. And then maybe I'll use another function. I might do an insert. We'll insert at 0. So at the start of the vector, we're going to insert the value of 9, right? So once I do this, if I now rerun that code, let's go to the top and rerun. Oh, okay, well, look at this. The macro list capacity is now 12, and the length is 9. So essentially what it's doing now is it's looking at the fact that I had all of these instructions, and this is added up to 6, and it's gone, okay, well, it looks like you're going to give me batches of 3 or 6, probably more likely 3s, right? So it's made an educated guess that the next time I want to add to this list, it's going to want to give me 3 items, right? So that's why it's increased its capacity to 12. And it kind of just does this inside of the application. The vector code goes, oh, okay, how much more should I, how much, how many more I should give in capacity based on what you're giving it or what you're pushing into it. All right, so that's the important distinction. Cool. So the last way that we can instantiate a macro, which is what you've seen with arrays, like this one up here, right, is we can use the same repeating syntax. Let me explain what I mean in a second. So let's go macro list 2 equals, and we can type something like vec. So we're using that vec macro still. We want to populate zeros 5 times. So you could do this with arrays, right? We saw it when we looked at arrays. So you can do the same thing here for vectors. And obviously because of that, and I probably should rename those variables. In fact, I might even just comment them out. So we'll take these 2 lines here, just comment out this whole section. And come down here and just do this. Cool. And once again, because I initialized it with an array of fixed values, you're going to see the capacity and the length is the same, okay? So that's pretty much the main ways you're going to want to populate a vector or create a vector, instantiate one, whatever. So what we're going to look at now is how we can access stuff that's inside of a vector. So let's say, for example, I have a list a vector with numbers already defined. So we'll go let number list equals vector, and we'll go from 1 to 8, right? 3, 4, 5, 6, 7, 8. And what have I done here? That number equals vector. What is going on here? That number list equals vector. I'm not sure what's going on with that. Let me just check to see. No, I'm in main. This is weird. Semicolon. Where's the semicolon? Okay, I'm just going to pause the video, guys, and I'll get back to you once I've realized what the problem is. All right, sorry about that. I did realize my mistake. It was a pretty silly one. So I had the exclamation mark at the front here. It was meant to be at the end, like that. That was just a silly mistake on my part. I apologize for that. I work with multiple programming languages, so sometimes I get the syntax wrong. Anyway, so we've created a vector list of 1 to 8, right? So this is a vector of I32s. And now say I want to look at what is in, or I want to peek at a particular item in this vector, right? So with arrays, we used indexing, right? We can use indexing here too. So we can do something like, get me the first number, and that would be at number list at 0, like that. And we can also go let last number equals number list. Let's say the 7 index, right? And if we were to print these two out, we can say first number is first number. And then we can do the same for last number. And last number, right? And what I'm going to do, just to make this easier on myself, I'm actually going to remove this code so I can actually access the run command sooner. So if I run this little program, you're going to see first number is 1, last number is 8, right? Because that's the index 0 and that's index 7. Cool. Same as arrays, no big deal there. However, and there's a slight difference between arrays and vectors, and that is, well, firstly, let's just cover off the similarities. So if I put let negative index equal, let's say -1, if I do something like this, number list at negative index, and I try to run this program, in fact, it's going to even complain at compile time that it can't do it. But essentially, it's saying you're trying to use this as a negative index, right? Use size negative is not satisfied. Okay, let me try it this way. This is not the idea I was thinking of. Let's try just -1 in here, like so, and then we'll just run this. And that was more what I was expecting, okay? So cannot use negative integer for indexing in vector, right? So basically that's indicating that you have a minimum of 0, right? You can't go any more than that. Otherwise, you're outside the bounds of the vector. Cool. But if I all of a sudden decide I'm going to give it an index of, say, 9, right, which is outside the bounds, I'm going to run it, and then I'm going to show you something. So it's going to fail, right? But the failure that we get, right, even though it says the length is 8, but the index is 9. So it's telling us that we're outside the bounds of the array, right? So it's broken. But because we're using vectors and not arrays, it will actually tell us this at runtime. It won't pick it up while it's compiling. This is different to arrays. If I come in and I create an array, say let equal, and we'll just go 1, 2, 3, right? If I try to go -3, which is outside the bounds, all right, it's actually going to tell me, hang on, yeah, that should be outside the bounds, right? When I run this, it's actually going to tell me at compile time that there was an error. It says this operation will panic at runtime. Not that it does panic at runtime, because we don't get to run it. We can't even compile it, right? So this is just a slight nuance that people need to be aware of when they're using vectors. Vectors will not prevent the application from compiling, but it will crash at runtime, right? This is different to arrays. Now, I probably think the reason for that, and I'm not quite sure to be honest, is that because it can grow and shrink over time, they don't want to stop you from, at some point in your code having the ability to see something at that index, right? Which is why it doesn't stop you at compile time. Whereas with an array, you always know what the size is going to be. So if someone's trying to do something that goes beyond the size of the array, then clearly they're doing something wrong, right? So that's my understanding of why vectors don't stop you from using indexes that are outside the size of the vector, is because of that dynamic nature that's in play. Cool. Last thing that we'll cover is just to be perfect in terms of reading stuff. Let's talk about looping. So we can do a typical loop. So first we'll create the list. Actually, I'll go back a couple steps. I'll keep the number list. And we can do a regular for loop like we've seen in previous videos, right? So we can say for num in number list, and we can print line these things out just like we did previously, right? So the point of this is that you can iterate over a vector the same way you can iterate over an array. Okay, so run, and there you go. 1 to 8 gets printed out. So there are some of the things you can do with vectors. I mean, we haven't looked too in depth yet. We haven't really added much to a vector. We haven't looked at how we can use vectors for certain data structures. And we haven't looked at something that allows us to access indexes safely. And it might be things like, we do happen to have a situation where we might think, there is supposed to be something at number list 9, right? We expect something to be there, but if something isn't there, we need to safely handle it, right? Whereas at the moment, if we use indexing, the application's going to crash, right? And we have to either catch that exception, which we haven't spoken about yet, or we have to let the application die, which is not ideal in some circumstances, right? So we'll look at a better way to handle that situation. But for this video, I think we'll just leave it there, and I'll see you all in the next one.